All right, so we have a 5 kilogram block that's being pushed by an applied force of 30 newtons. The applied force is downwards on the block, so I put a negative 38 degrees. The negative sign won't matter so much in this case. I'm really just, but it is downwards, so it indicates direction. But we're really, when we calculate forces and component forces, you really just need the magnitude of those, the values of those forces, and you can decide based on the drawings what the directions are. Anyhow, it is negative 38 degrees. 30 Newton force. This is like you want to push a box horizontally across the floor. You're pushing your Christmas ornaments towards the tree, and you don't want to get all the way down and push that way. Instead, you're pushing down like that. Or maybe you're pushing on a cart in the store. Your force is down that way, but the cart rolls horizontally. That's what this represents, okay? It's moving on the floor with constant acceleration, uniform acceleration. There is friction present. So that's the first thing we're going to need to calculate. Before we can do that, we need to draw a force diagram. So here's the dot representing the 5 kilogram block. You know that you have a normal force, the force of the floor or surface up on the block. So you have a normal force up there, lowercase n. Excuse me. You've got the weight of the block, which would be 49 newtons, right? 5 times 9.8, mass times g. That's going to be 49 newtons. You have the 30 Newton applied force down at that direction, so it's downwards. That's the direction that you're pushing. You always draw these arrows out of the dot. And then the block is sliding to the right horizontally, so there is friction back. The friction acts back that way between the surface and the block. So the friction is this direction. Okay? Kinetic friction. All right. So, first thing I'm going to do is figure out the normal force, because I need the normal force to find the friction. I'll find the normal force in the y-axis. So the net force in the y-axis is 0. That's in the vertical axis. The up and down axis is 0. All right. How do we know it's 0? There's no acceleration in the y-axis. It's accelerating horizontally. But there are forces in the y-axis. They must be in equilibrium. They must balance each other out. So you have the normal force pointed upwards. And then it's balancing the two downward forces. You have Fg pointed downwards. And then Fa is not pointed down. The y component of Fa is pointed downwards. So we have to find the portion, the downward portion of the 30 newtons at negative 38 degrees. Okay, in order to do that, we're going to have to draw, we're going to have to resolve this force into its component vectors. I'm going to draw a separate arrow, make it a little bit bigger, to be able to figure out that value. I just do that over here. So that represents this applied force. Okay, that's Fa, and you know that it's 30 newtons. Excuse me. This is negative 38 degrees. This is the component, the horizontal component, what we'll label as Fax of the 30 newtons. So how much of the 30 newtons is horizontally to the right? That's what that represents. And then going downwards, that's Fay, the y component of that applied force. I've already done the math here. And when you find this, well, that's going to be 30, all right? Hypotenuse is 30 times the sine of negative 38. And I'm really not interested in the negative sign. We're going to get a negative value. I hope that doesn't confuse you too much. If you don't put the negative sign in there, it's okay, because I'm going to put the magnitude here. I've already taken into account the directions. The normal force is on the left-hand side of the equal sign because it's upward, and these two are on the right-hand side of the equal sign because they're downwards. So I'm not going to actually end up using this negative sign over here. But it is mathematically correct. It's not a big deal. I hope that doesn't confuse you too much. So that came out to be negative 18.5 newtons. I also calculated FAX. That's going to be the hypotenuse of 30 times the cosine of negative 38. And if you put positive 38 in there, the cosine of negative 38 and positive 38 are the same number. So that came out to be, let me see if I can find it, 23.6 newtons. Okay. So to find the normal force, the weight is 49 again, the mass of the block times 9.8, Fg equals m times g. So that's 49 plus 18.5 newtons. Again, why didn't I put the negative sign? Because I've already taken into account the fact that both of those are pointed downwards. All right, that's what that remember in physics, negative sign just denotes direction. It's pointed downwards. That's why it's on the right-hand side of the equal sign, because these are the downward forces. The 49 newtons and the 18.5 newtons are both downwards. Normal force is upwards. They balance each other. Okay. Let's add these up and see what we get. Normal force adds up to, according to my notes, it adds up to 67.5 newtons. Okay, next, let's find the friction. Kinetic friction equals mu, the coefficient of kinetic friction, times the normal force. And the coefficient of kinetic friction in this problem, I believe, was 0.25. All right, so that's a variable I forgot to write down. Remember that coefficients of friction do not have any units. Don't put a unit next to it. And also remember that it's not the friction, it's the coefficient of friction. You have to multiply the coefficient times the normal force to get the value of the actual friction. So 0.25 times 67.5 equals 16.9 newtons. Okay, so we've got the value of the friction. Now I can find the net force in the x-axis. Well, the net force in the y-axis is 0, so the only unbalanced force will be in the x-axis because that's where the acceleration is. Remember, acceleration is due to an unbalanced force. And the acceleration is always in the direction of the unbalanced force. If the thing's accelerating in the horizontal axis to the right, then the net force must be in the horizontal axis to the right, period. So, in the x-axis, net force in the x-axis is going to be the difference between the x component, the horizontal component of the applied force, that's F(AX). That's the force to the right, less the force to the left, which is the kinetic friction. That's going to be 23.6 minus the 16.9. Again, it's the force to the right minus the force to the left. It doesn't equal 0 because it's accelerating. That comes out to be 6.7 newtons. So that's the value of the net force. It's not just the net force in the x-axis, that's the overall net force, because there isn't any other net force. Net force in the vertical axis is 0, so that's the unbalanced force. It's unbalanced horizontally to the right, which causes the thing to accelerate to the right. Now we can find the acceleration. You know that Sir Isaac Newton tells us that acceleration is net force all over mass. So 6.7 divided by 5, which came out to be 1.34 meters per second squared. Okay. And we're done.